Okay, so welcome to this September 15th, 2023 edition of the Master of the Skies Weather Briefing Show, where we talk all things weather. And so today we're going to be talking about Hurricane Lee, that's situated off the east coast of the United States currently. And you might have heard of Hurricane Lee. He's been churning out in the subtropical Atlantic for some days now and had even attained the intensity of Category 5 at some point. And now has weakened quite substantially as it's starting to accelerate northwards towards the Canadian Maritimes. And it's currently located some miles to the northwest of Bermuda. And you can see a visible satellite picture of it right here. And so we're going to be talking about its weakening phase right now, why it's weakening, and what can be expected over the next 12 to 24 to 36 hours as this hurricane continues to weaken and moves on to the north. So maybe to start out, let's put this satellite imagery into motion, and you can see the first thing you can see with this hurricane circulation is that you can see the low-level clouds that are turning counterclockwise, which would be expected in the northern hemisphere around low pressure. And so you could see the circulation, you could see the eye of the hurricane still visible here. And what you could also see is this sort of clockwise flow that you can see here with these high-level cirrus clouds. And this is actually a reflection of the upper-level outflow of the hurricane, which actually helps to ventilate it from the top. And so usually healthy hurricanes have good upper-level outflow, which means that it's ventilating the circulation from below and helping also the convergence of winds at low levels around its center. And so here you could actually see some upper level outflow cirrus being advected northwards all the way towards the New York City area over eastern New Jersey and into southern New England. As this is really upper level winds and clouds that are actually turning clockwise. So that contrasts quite vividly with the mid to lower level circulation, which is actually spinning in the opposite direction. Now, what you can see here is, and we'll be looking at this in a second, it's starting to encounter some unfavorable conditions, atmospheric conditions, which is starting really to weaken it quite rapidly. And first of all, you can see that you don't really see a lot of cloud mass on the southern end of the storm here. You actually see quite a bit of clear skies down here. And that's due to some dry air that's starting to be advected into the circulation to the south of it. And we can actually see this if we take a look at some of the model forecasts. Here we're looking at the GFS model on Pivotal Weather website, and you can actually see these brown tones, which reflects dry air at about 10,000 feet or 3,000 meters at the 700 millibar level. And if I put this into motion, you can see the hurricane circulation here to the east with all this moisture. But as you move forward in time, you can basically see that a lot of this dry air wraps around the circulation and starts to starve off a lot of the hurricane. And you can also see this on the precipitable water, which is a reflection of how much water vapor you have in the atmosphere at any given moment. And you can see also that some of these drier values, as you move forward in time, is being affected in around part of its circulation, and that's never really that good. And that's due to the fact that hurricanes really they really feed on hot and moist conditions, and they need warm ocean waters beneath it as well to thrive. And so when you start advecting dry air into it, it's usually not a good sign for the health of the hurricane. Another factor that's leading to its progressive demise is it's encountering some rather strong southerly upper level wind shear. And you can see that here too, where you can see a lot of, on the northern end of the storm, you see a lot of deep cloud material associated with the hurricane, whereas to the south, you're only left with basically the low level circulation. And you could see, so it really contrasts on the southern end, which is also being advected with this dry air, but also the upper level winds is really pushing all this upper level cloud material associated with the hurricane, the dense overcast cirrus shield, which is being pushed northward ahead of the system. And so you're basically getting sort of a decoupled hurricane circulation system where the upper level circulation is being decoupled from the low level circulation. So that's quite interesting to see. And you can actually see it quite well as well if we look at the infrared enhanced. You could also see that with these blue and green colors showing the cold cloud tops associated with high clouds, and that most of them are located on the north side because all of this cloud material is being blown off to the north. You could also see it here a little bit better, where you could see the low-level circulation and then the upper-level circulation, and that's being sheared to the north rather quickly. Now we could also look at some of this this shearing going on if we take a look at what's happening with the winds. Now this is the circulation based on the European model at the surface with the isobars plotted. You can see we still have a rather low sea level pressure of 966 millibars or 966 hectopascals, and you can see these blue and violet tones corresponding to the wind speed, and the closer you are to the center of the circulation, the higher the wind speeds until you get to the center of the eye where usually the wind is rather calm since you have sinking air there. But right around there, that's where you have the highest winds. Now, if I sort of go higher and higher up here, and before I do that, let me just plot the geopotential height, and then as you go up, let's say we'll go up to about 250, which is really high up there, and I sort of zoom out, you could sort of see, for those of you that followed my ebook and maybe my training course, you know that we, at some point when we talk about upper level flows, we talk about split flows and the subtropical jet. You can see sort of split flow here where you have the subtropical jet actually interacting with a part of the hurricane, and it's increasing the shear. And so you have this subtropical high to the east, which is piloting the storm to the north, but also this subtropical jet, which is helping it also to steer it really northward right off the east coast. And so whenever you get this shearing going on due to upper level jet energy, that's never good for hurricanes because they usually thrive under rather anticyclonic conditions with weak winds aloft. And once you start inserting too much vertical wind shear over a hurricane, that usually tends to weaken it quite rapidly. So that's actually what's going on with this system. Now, if I go back, what we could take a look now also, which is interesting, is to take a look at the sea surface temperatures, because that's another factor that's important for hurricanes to maintain their intensity. And if I zoom in here, let me get the isobars off, and what we could do is take a look at with regards to where the hurricane is right around here. Let's take a look at some of the temperatures here. They're rather quite warm with about 80-degree temperatures, and even some higher temps of 83 or even 84. So that's probably in the 25 to 27 degrees Celsius range. Now, that's usually the temperatures that you need for hurricane formation, but as the hurricane will be migrating to the north here, as it's being really driven northward towards the Canadian Maritimes, you can see it will quickly advect over much cooler surface waters, and that's usually not enough to sustain a hurricane, since it really thrives on this heat and moisture from warm subtropical oceanic waters. So as a hurricane continues to move north, it will continue to weaken due to the dry air advection, the unfavorable vertical wind shear, and in these cooler ocean temperatures that we'll be confronted with as it moves towards the north. So that's basically what the National Hurricane Center in Miami is forecasting. You should, if any of you are interested in knowing what it will do next, certainly go on to their website. That's really the official information. And you can see that this is their track as over the next day or two as the hurricane moves to the north. It still has winds of about 80 miles an hour, or about 130 kilometers an hour. Maximum sustained winds near the center, but it's rather a large storm, as you saw in the satellite imagery. And so actually hurricane force winds extend outward to about 100 miles or 165 kilometers from the center, and tropical storm force winds extend outward to about 320 miles or 520 kilometers from the center. So it's really quite a huge storm, and that's why the National Hurricane Center actually has a tropical storm warning for a lot of the New England coast north of Boston, also the Cape Cod area, towards the southern coast of Maine and into Nova Scotia over the Canadian Maritimes. And the hurricane is expected to be downgraded to a tropical storm before it makes landfall, and will probably tend to become extratropical rather quickly as it's interacting with upper level jet stream energy, and it will really quickly lose its tropical characteristics as it's taken into the westerly flow loft towards the northern Atlantic. So that's basically what's going on with Lee. And of course, if you read their hurricane discussion at the National Hurricane Center, they also talk about these weakening factors that is leading to Hurricane Lee's demise. Now, another thing that was pretty interesting, when the hurricane was still a Category 5 storm a few days ago over the subtropical Atlantic, the NOAA Hurricane Hunters actually flew into the eye, as they usually do, to get some critical information to help weather forecast models better predict what their future direction and intensity will be. And typically they fly through the lower parts of the storm, through the different rain bands and the eye wall, and then they go into the eye where it's usually pretty calm. And this is quite amazing video where you could see actually constant intracloud lightning being filmed as the Hurricane Hunter is actually in the eye. And that's the basically the eye wall, which is usually the most intense part of a hurricane. And you can see how much lightning activity is actually present in these thunderstorm towers within the eye wall. You're actually looking upwards. This is actually clear skies up here because you're in the eye where the air is sinking, and then right around it the air is rising in a circular manner very rapidly, and that's really quite intense. This was back on September 7th, and that's quite amazing to see. So don't hesitate to go on their Instagram feed to get other information also about what they do. And of course, for those of you who are not familiar with the hurricane structure, of course, you have the eye in the middle here, but you have these outer rain bands that actually usually are composed of showers and thunderstorms. And the closer you get to the eye wall, the stronger the winds become, where they become the most intense right around the eye. And then when you go into the eye, actually usually the winds calm down quite a bit, can even become calm, and usually you'll get some kind of clearing of the skies as the air above is actually subsiding, and so evaporating any cloud material. Another great shot of it is here. So you have the eye here in the middle, and then you have this mid to lower level circulation that's actually counterclockwise in the northern hemisphere around the circulation center. And this is really where the strongest winds are as they rise progressively to the top of the hurricane. And then you have the upper level outflow, as we saw, that actually spins in the opposite direction in a clockwise fashion as it's ventilating basically the hurricane and helping the air continue to feed into the eye wall at lower levels, while in the center of the eye you have actually descending air, which is actually evaporating the clouds and leading to rather clear skies and calm wind conditions. So that's basically the structure of a hurricane, and helps to explain also why you can see this, what you're actually seeing here in this pretty impressive video from the Hurricane Hunters. So there you go, and I think that's about it for Hurricane Lee for tonight. Don't hesitate to also go on my Instagram feed, where you could also get other information about weather forecasting in general, and also can see some of the products that I usually propose. And also, of course, my YouTube channel, where you can see previous videos of different weather forecasting information in order to explain a little bit how weather forecasting works. So there you go. Thanks for watching, and we'll see you next time.